In this video, we will discuss rare events and how we generate a hypothesis test. And this is section 9.4 in the Introductory Statistics OpenStax book, titled Rare Events, the Sample, Decision, and Conclusion. And in our Statistics OER course is section 8.4 with the same title. So, the way we will conduct a hypothesis test is that we will make an assumption about a property of the population that is called the null hypothesis. And then we will gather sample data randomly. And if the sample has properties that would be unlikely to occur if the assumption were true, then we would conclude that our assumption about the population is probably incorrect. That is when we will reject the null hypothesis. Now remember that the null hypothesis is not a fact, and we don't know if it is true or false. But the data we collect from the sample is real, and the data are showing a fact that may contradict the assumption. So how do we determine if the data is real? We collect the sample data and we compare it to what the expectation is for the population based on the null hypothesis. This is called the p-value, is the probability of getting this sample out of the theoretical population. And I want to remind you of an experiment we did in Unit 3. Where we were trying to pull a red card from a deck. So our null hypothesis is that this is a standard deck, has 52 cards. Half of them are red, hearts or diamonds, and half of them are black, spades or clubs. And when we collect the data, which is our sample, so we start drawing cards, and we see that we keep drawing black cards, then we have a result that is unlikely to occur from the hypothesis that this was a standard deck. So if we have a very small probability of producing a sample that is all black cards from a standard deck, then we will assume that we will claim that we have enough evidence to assume that the hypothesis was false. The hypothesis was this is a standard deck that has half red and half black cards. So going back to our hypothesis, the p-value is the probability that if the null hypothesis is true, the results from another randomly selected sample will be as extreme or more extreme as the results obtained from our given sample. If we have a large probability, so if we did get enough red cards and enough black cards to have an outcome that seems possible to occur, then the sample data is likely to come from the assumed distribution of the population, and we cannot reject the null hypothesis. But if we have a very small p-value, in the case of pulling only black cards, we ended up with a very small p-value eventually because we were multiplying 1/2 times 1/2 times 1/2 times 1/2 many times, and we ended up with a very small probability of coming from a standard deck, then we have an unlikely outcome. And this is strong evidence that the null hypothesis is false. So we can reject the null hypothesis. So we would reject the null hypothesis if the evidence we have strongly indicates that this sample or a more extreme sample has a probability of occurring less than alpha, alpha being the significance of the test. So we want to make sure that we always draw a graph that shows the p-value. P-value is the probability of having an outcome as extreme or more extreme than your sample. More extreme means towards the tails of the distribution. And a hypothesis test is easier to perform if you graph and you see the problem clearly. You want to see where your sample is located in the distribution of the theoretical population, which is your null hypothesis. So let's try to do a couple of examples here. A baker claims that his bread height is more than 15 centimeters on average. Several of his customers do not believe him. So to persuade his customers that he is right, the baker decides to do a hypothesis test. He bakes 10 loaves of bread. The mean height of the sample loaves is 17 centimeters, and the baker knows from baking hundreds of loaves of bread that the standard deviation of the height is 0.5 centimeters, and the distribution of heights is approximately normal. So, what is the null hypothesis? The null hypothesis has to contain the equal sign. We are talking about a height, which is a continuous variable, numeric. So the mean of the population will be less than or equal to 15 centimeters. And the baker thinks that the alternative hypothesis that he's trying to prove is that the mean is greater than 15 centimeters. Do we know sigma? Yes, we do. The baker knows from baking hundreds of loaves of bread that the standard deviation of the height is 0.5. centimeters. So we know that sigma is 0.5 centimeters. And what are we going to estimate when we collect the sample of 10 loaves of bread? And the variable that we will be estimating is the mean height. We will be estimating mu with our sample mean, x bar. So, what distribution are we going to work with? We will work with a normal distribution for the sample mean, and that is because we know the standard deviation of the sample, of the population. So if you remember from our previous section, if we have a hypothesis test of a single population mean and we use the normal distribution, then we know the population standard deviation. So therefore, we will use a normal distribution. If you remember, the normal distribution has a mean of what we think the null hypothesis states as the mean of the population. That will be 15 centimeters. And it will have a standard deviation, the standard deviation of the variable divided by the square root of n. So in our case, we will have a normal distribution where the mean will be the 15 here, and the standard deviation will be the 0.5 divided by the square root of 10. So I will use art of stat for this, and art of stat does not accept expressions for the place of the standard deviation. If I used my calculator or Excel, then I would be able to enter this expression. So I'm going to try to find the value of 0.5 divided by the square root of 10 with as many decimal digits as my calculator will produce. So I did this in my calculator. It came to be approximately 0.16. Of course, when I use my technology, I will use as many decimal digits of accuracy as I can. And when I sketch, I want to sketch numbers that I can actually interpret and see and understand. So assume that the null hypothesis is true. The mean height of the loaves is no more than 15 centimeters. Then the question is, would an x bar of 17 centimeters be unexpectedly large? So the hypothesis test works by asking this question: how unlikely is x bar equal to 17 centimeters if h sub 0 were true? Now, if h sub 0 were true, we would have a normal distribution. And here it will be the mean height of loaves in centimeters, sorry. That will be our variable. And it will have a mean of 15 and a standard deviation of 0.16 approximately. So remember that the normal distribution usually goes 3 tick marks to the left and 3 tick marks to the right. And the values will be increments of 0.16. So 15.16, 15.32, 15.48, and on the left 14.84, 14.68, and 14.52, and a sample mean out of 10 loaves of bread of 17, which is really far to the right. It's actually somewhere here, 17. We'll have a probability of being this much or more extreme of something really small. So I would like to find that probability approximately. So I'm going to go in art of stat under the normal distribution, and I'm going to enter this information. So I'm going to select the normal distribution app, and I will go under find probability. The mean is 15 and the standard deviation is 0.1581138883, and I need the probability in the upper tail because the 17 was too high, of being 17 or more. So when I have such an extreme value, I see here that art of stat gives me an error. I'm going to try to, let's make it a little smaller. So you see here that because every increment is just 0.16, it takes way too many tick marks to even reach 16. So when I'm even further to the right, the software cannot even graph that far or calculate that far. So it can calculate probability of x being greater than 16 to be approximately 0. Here it's very small, but after I go even further away, the probability becomes 0 even in the abilities of art of stat to calculate. So the question therefore is, how unlikely would a mean of 17 centimeters over 10 loaves of bread or more extreme would be if the null hypothesis were true? And the probability of this occurring, so this is the p-value here of actually having a sample of 10 loaves having a mean of 17 or more, is approximately 0. So the p-value is the probability that if we were to take other samples, any other sample mean would fall at least as far out as 17 centimeters. And the p-value is the probability that the sample mean is the same or greater than 17 centimeters when the population mean is in fact 15 centimeters. So, and again, here I am asking for an upper tail, and I'm asking for this value of x to be 17, but I want 17 or greater. That's why we are selecting the upper tail. Now remember that I was getting an error because art of stat was not able to calculate that far away from the theoretical normal distribution. So mathematically, the p-value that we are calculating is the probability of x bar being greater than or equal to 17, and it comes out to be approximately 0. And we used the normal distribution for the means to calculate this probability. Remember, it has a mean of the mean of the population and a standard deviation, also called the standard error, of the standard deviation of the population of one loaf of each individual loaf of bread divided by the square root of n. A p-value that, like ours, which is approximately 0, tells us that it is highly unlikely that this particular sample of 10 loaves came from a population that abides by the null hypothesis, which said that I would have a mean of 15 centimeters. That is, it is almost 0% likely that of all loaves of bread, we will get a sample of 10 loaves that has at least as high as 17 centimeters height purely by chance, had the population mean height really been 15 centimeters. Since the outcome of 17 centimeters is so unlikely, then I can conclude that I have enough evidence to reject the null hypothesis, meaning that the height is at most 15 centimeters. In fact, my conclusion will not be, my decision will be to reject the null hypothesis, but my conclusion will be that I have evidence to support the alternative hypothesis, which is that the mean height of loaves is greater than 15 centimeters. So that will be my final statement. The evidence will allow me to reject the null hypothesis, but then my statement will be my conclusion that says that I have enough evidence to support the alternative hypothesis.